is on. Awesome. Yes, so we're starting with today's 13th August, eh?
Yes.
2024. And we are learning factorization. Do you mind paging to the last page we finished at? Was it this one? Yes, we did this. Okay. Please start reading from there.
When you have a square of a binomial,
Okay.
write out both brackets and then use the FOIL to find the product.
Okay. Let's start here. Do you know what the word binomial means? Do you have a sense at least of what it means?
Yeah.
Okay. Can you explain it to me what you think it means?
It's like, trinomial and
Don't say because I'm you're telling it to me like I don't know. So put yourself in a position where you would understand it. You're explaining it to someone like your niece who doesn't know it. Yeah, let's try it like that.
I don't know, like to
Okay. So
explain it.
okay, let me just make it more understandable. Ne? So the part that says nomial, ne? It's like a term, ne? A term. So it could be a polynomial expression, for example. E.g. expression would have, let's say, 6x to the power 7 plus 3x to the power 6 minus 8x to the power 5 plus 4x to the power 4. You see? So all of these things, this is a term. Or we could say nomial. We could call it a nomial. But we can also get another explanation from a different source in case I'm giving you half the information, because half the information is also as dangerous as wrong information. Yeah? So let me rather give you another opinion so that you don't rely on mine alone. And the only reason I'm doing this is because it's only fair. Yeah, it's only fair that you get correct information, because you're the one who has to write the test. So if you don't understand and I gave you wrong information, then I mislead you. So that's not fair on me. So, but anyway, you'll see words with this part a lot: binomial, polynomial, etc. Right? And when we multiply them out, we'll always refer to BODMAS. Yeah. But in this case, where we factorize, we'll use FOIL if it has got, like if it's brackets like that, always squared. You ended reading up to here, ne? Up to there. Okay. Okay, that's fine. I just want to quickly open. Yeah, so this one is finished loading. Binomial. Okay, let's see. Binomial. Okay, so binomial definition, operations, example. Okay. A binomial is a polynomial with only two terms, right? So a polynomial expression will have multiple of these terms, right? But a binomial, the part, so it just means multiple terms, né? But a binomial equals two terms. So in this case, it will be x minus a, or x plus 2, or let me use another alphabet, y plus 2, or something like that, né? So that would be the kind of polynomial expression that has two terms in it. So this is not a binomial. If you have 2x, it's not a binomial. If you have 3y, it's not a binomial, because it is an unknown with a coefficient, and these two are a product. They make one term. So this is one term, therefore not a polynomial. Yeah, so polynomial just means multiple terms with varying degrees for x, varying powers, different powers for x. Ne? All right, so carry on reading.
Brackets in the form a minus b to the power of 2, or bracket a plus b bracket to the power of 2 are called perfect squares.
Okay, so perfect square it's a minus b all squared, or a plus b all squared. And the reason for this is because there is a very straightforward way of factorizing these. Oh, yeah, just click there. Yeah. So there's a very straightforward way of squaring this. So this, for example, a minus b all squared, for an example, would equal a squared minus 2ab plus b squared when you apply FOIL, ne? So after applying the FOIL method, FOIL method, ne? And a plus b all squared will equal a squared plus 2ab plus b squared. This also means that if you have x minus 2 or y plus 3 all squared like that, then this would be x squared minus 2x plus 4, and this would be y squared plus 3y times 2 is 6y plus 9. And also, when you practice these kinds of problems a lot where you factorize, ne, you will learn whenever I see a trinomial expression like this, a 3-term expression like this, and it's got x squared minus 2x plus 4, then I can factorize it like this. So it will be x minus 2, x minus 2, because that's what this means. Okay, let me do this. Let me roll back the tape. Okay, they're called perfect squares because what you're going to apply to them is a minus b times a minus b, right?
Oh, because to the power of 2
means it multiplies itself.
twice times.
Yes,
Okay.
it multiplies itself twice.
Ah.
So if you would have 3 there, it would be 3 of those. If you had to have 4, it would be 4
Four
of
there,
those.
okay.
Yes. So it's the same as saying if you have x to the power 2, it's the same as x times x. And if you have x to the power 3, it's the same as x times x times x. So it's the same type of thinking. I guess I was a little bit too forward. But but the long story short is perfect square, because it will be a squared minus 2ab plus b squared. And you will learn these methods that they're useful when you're proving things even in trigonometry when you get to grade 10, 11 and 12. But you'll get there should you decide to do maths after this year. And this would be a plus b, a plus b. Now here you apply FOIL in both cases, FOIL. Because what happens is you will start by multiplying the a times the a, and then you multiply the a times the negative b and the negative b times the a. Oh, let me use one color for those two. And then this one would then multiply like that. So that, and I'm using these colors so that you can see where which term comes from. Ne? Yes. You see, when you apply the first, outer, inner, and last method, the firsts, which are in blue, the a multiplies the a, and you get a squared. It's this idea here. When you take a and you multiply it by negative b, you get negative ab, the first one. And then you get, okay, maybe let's do this again so that it's less confusing. Right, so you will have a squared, that's the first one, right? And then you'll have minus ab, which is the first green one. Yeah, so it's that one there. And then you will have another minus ab, which is the second green term. And then you will lastly have negative b times negative b gives you positive b squared. That's because, firstly, negative times negative is positive, and negative times positive is negative, positive times negative is negative. So the negative sign changes the sign. Positive doesn't change the sign, but the negative changes the sign. And positive times positive gives you positive. So what happens is you will get negative b times negative b. So we're going to have negative times negative is positive. And then we take the b times the b, which is b squared. Same as there. So then you'll have b squared. You can also look there so that you don't feel uncomfortable. But if you're comfortable looking this way, it's also fine. That one. And then in the end, we end up having a squared minus 2ab plus b squared. And we have minus 2ab for the simple reason that when we have these terms, ab and ab, we're not multiplying them. The bases are the same, so it's a and b, or it's rather a times b and a times b. So we simply work with what the signs tell us. So if it's two negatives, we treat them like integers. So if you have negative 3 and negative 4, for an example, that will equal negative 7. So we add them just the same. Or we operate them just the same, let me put it like that, because we are not multiplying. So in the end, they become negative 2ab. That's what happens with them, right? Here, it's the same thing. A squared plus AB plus AB plus B squared. And this gives us A squared plus 2AB plus B squared, right? Green would be these two, and yellow would be these two, right? So to be that multiplied by that, and that multiplied by that, that multiplied by that, and that multiplied by that. So these two, we also operate them like that. So this would be x squared minus 2x minus 2x plus 4, or rather, let me not do the same mistake again. X minus 2, x minus 2. We apply FOIL. So we will have x squared minus 2x minus 2x plus 4. And how we can visualize that? First,
Plus 4.
Yes, plus 4. You want to know why?
Yeah.
Because it is the negative 2 times the negative 2. Which is what we get when we multiply the last ones. Okay. Yeah? So that would be negative 2x plus 4. All right. So it's this one that we have here. You see? So that's why it's plus 4. Then we have negative 2x, and then eventually it becomes x squared minus 4x plus 4. You follow?
Yeah.
Okay. And then we can also do the same. So I want you to notice now, this one looks the same as that one, and this one works the same as that one. So let me just do this so it's less confusing. So here we'll have y plus 3 equals y squared plus 3y. So let's do this. That's the first one, I get. Then the second one is outer. Then the third one is inner. Then the last one is last. Ne? So that would be plus 3y plus 9. So that means we'll have that and that and that. Ne? And then this becomes y squared plus 6y plus 9. So we've just done the same thing here as we did up there.
Yeah.
Only this time we added numbers to the mix. And maybe we changed the a and we made it x, or we made it y. But the same way we operated for this one is the same way we operated for that perfect square. And the same way we operated for this perfect square is the same way we operated for that perfect square. Now you will learn, the more you practice perfect squares, that it will be easy to identify perfect squares. And this becomes useful when you're proving, say, cosine rule in trigonometry in grade 11 or 12, or if you have to work on some other algebraic problem, or maybe you are looking for the factors of a parabolic graph, because this will draw a parabola. This will draw a parabola. Ne? But we'll think about that later. For now, carry on.
If you multiply out a perfect square, you get a trinomial with a square at each end.
Right. So basically, this is a trinomial. Ne? Tri means three. Trinomial. So it's a three-term expression. Ne? Three terms. And you get a square and another square at the beginning and at the end. The one in the middle is not a square, but the one that starts and the one at the end, they give you squares. Yeah. So, and that's what is meant by this. So the one in blue and the one in yellow, they are squares. Only if it's a perfect square. Only if it's a perfect square. Carry on.
The middle term is the double the product of the terms inside the bracket.
Okay. So what that means is, okay, let me just go back here. Ne? So when you have a perfect square, the best way to expand it or write it out in full is you will say, if I have a minus b all squared, then I will square the first term, I will square the second term and put it at the end, and in the middle I multiply these two and then I multiply them by 2. You get it? So here it's a, I square it. It's b, I square it and I put it at the end. And then I take a, I multiply it by negative b, and then I multiply that answer by 2, and I get negative 2ab. Here I also do the same. I take a, I square it. I take b, I square it. I take a multiplied by b, and I multiply that answer by 2. You look at it here. I take x, I square it. I take negative 2, I square it. It gives me positive 4. Then I take negative 2 times x. It's negative 2x. And I multiply it by 2, and I get negative 4x. Same here. Y squared, positive 3 squared. 3 times y is 3y, times 2 is 6y. And then I have my trinomial, which expands my perfect square. So that's what that means.
Okay.
Yeah. Then carry on.
Yeah.
Yeah. Carry on.
For example, bracket 5y minus 4 bracket square.
Okay, let's do that one. Okay, but read it out first. We're gonna do it after you finish reading it out.
Equals bracket 5y minus 4 bracket 5y minus 4. Write out both brackets.
So we've taken 5y minus 4 all squared. Then we write it out like that. Ne? then what we can do is multiply each. So 5y times 5y will be 5 times 5, which is 25. Y times y, it's y squared. So we've squared the first term, 25y squared. The last term is negative 4. So it's negative 4 times negative 4. It will be positive 16. Because 4 times 4, it's 4, 8, 12, 16. Right? 16. So we will have something like negative 20 times 2, negative 20y, negative 20y, and then this will be 25y squared minus 40y plus 16. So in other words, square the first term, square the last term, multiply these two, and then multiply them by 2. Now, so that's the simplest way you can think about it. If you check your answer and you ask yourself, is this the first term squared? Ding! Is this these two terms multiplied by each other and then multiply them by 2? Ding! Is this term squared? Ding! Then you get full marks. That's how you can also check yourself. Now, just finish off that paragraph, then we can get to the next page.
Use FOIL to find the product 25y squared minus 20y minus 20y plus 16 equals 25y squared minus 40y plus 16.
All right. So then, yeah, we can finish there. Then let's get to the next page.
The first and last terms are always positive as they are perfect squares.
Okay, so what that also means is, if you checked, the first and last term, there hasn't been a negative in either of them. Yeah, if we go back to the previous slide, we've always got a positive, 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 positive. You see? So, and that is also because this is a perfect square. Yeah, that's what that means. So because it's always perfect square, we always have positive and positive. Maybe in the middle we might have negative, if you have a negative sign there. Yeah. So those are the differences between these two, but they work the same. Okay, and then the next
middle term of the trinomial takes the sign inside the bracket.
Okay, so what that just means is, because it's negative there, then the middle term will be negative. If it's positive there, the middle term will be positive. Negative there, negative middle term. So negative in the middle of the bracket, negative middle term. Positive in the middle of the bracket, positive middle term. And that's all the time when you see a perfect square. That is always the case. Okay? Middle there, middle negative term, positive there, positive middle term. Yeah. Then carry on.
Brackets 3a plus 4b bracket square equals 9a square plus 24x plus 16b square, but bracket 3a minus 4b bracket square equals 9a square minus 24x plus
16b
b
squared.
square.
Okay, so again, what is explained there is that positive inside the bracket will give us positive middle term, and negative inside the bracket will give us negative middle term. So let's quickly do this one. So that first way to express this would be to write it out as brackets: 3a, 3a, 4b, 4b. Ne? Then we multiply the first ones. It's 3a times 3a. That gives us how much?
9a
9a.
square.
9a squared. Excellent. So again, you have to mention the squared so that also in your mind you remember that it's squared. Ne? Then so we've done the first, and then we do the outer ones. So the outer is 3a times positive 4b, and how much is that?
12a
12a.
square.
It's 3a times 4b.
12ab
100%. So it'll be 12ab. Then we do the ones on the inside, the inner ones. It's also again 3a times 4b, but it's the same as 4b times 3a. So what is the answer there?
12ab
12ab, excellent. And then we do the last ones. What's the answer? If we multiply 4b times another 4b by another 4b,
4b
times 4b. Yes. How much is that?
16.
Okay, 16. That's not complete.
AB b
16b
square.
16b squared. You sound unsure, my friend. You sound unsure. Eh? And then we finish off, ne? So it'll be 9a squared plus 24ab plus 16b squared. Alright? Then we do the same here. Again, positive inside the bracket, positive middle term. Yeah. Then here, it's 3a minus 4b, 3a minus 4b. What do we get when we multiply the first ones?
12.
3a times 3a is how much?
9a square.
Excellent. And then 3a times negative 4b.
Negative 4b.
So 3a times negative 4b would be how much?
12. Minus 12.
What else?
AB.
Excellent. Say it in full. Don't be shy. Minus 12ab. And then we take negative 4b times 3a. What do we get?
It's 12
Is it positive or negative?
minus
It's negative 12. What else is there?
square. B square.
We're still doing the inner ones. We're multiplying AB, yes. And then we finish off. So negative 4b times negative 4b would be how much?
Minus
The negative multiplies another negative, so what happens to the sign?
Plus.
It becomes positive, yes. So it's 4b times 4b, and how much is that?
16b
16, just b?
squared.
16b squared, okay. You'll need to practice a lot more these perfect square examples so that you, yeah. But anyway, so we have 9a squared minus 24 ab plus 16b squared. That's the answer. That's the answer. Again, negative inside the bracket of the perfect square gives us negative middle term. But again, perfect square gives us square the first term, square the second term, multiply the two terms and multiply them by 2. And if it's negative there, it's negative there. If it's positive there, it's positive there. That's the long story short.
Do I have to read?
Are you feeling tired of reading? I want you to get into the habit of reading the theory so that it explains to you and you hear it out loud through your own voice. That's the whole point. Does it make you feel uncomfortable? Okay. How would you suggest we go forward?
Like how?
So that we can go through the theory and then we do the examples. How would you suggest we do that?
By doing the
Examples?
Yeah.
Okay. And then what about the theory?
I mean,
Hmm?
I mean, there's like
Okay.
time here.
And what about problems that don't have those explanations? You see, it's work that we kind of don't like, but we have to do it anyway so that we understand. That's the whole point. So we all have to do things that we don't like to enjoy the things that we want to enjoy. That's just life. So don't feel bad about it. Let's carry on. So in topic 8, you learned that when you multiply two binomials together that are identical except for the sign in the bracket, the middle two terms will cancel each other out and the result will be a binomial difference of squares. Okay. So we've done perfect square, right? And perfect square has the format of, I guess you could write it out like this. So a perfect square would be a plus b squared or a minus b squared, right? That's a perfect square. Now it says topic 8 on your book. I'm not sure which part that is here. But yeah. Topic 8. Okay. And what they're explaining there is if you have, let's say, a plus b times a minus b. What happens when you have a plus b times a minus b? What do you think happens there?
It's
Isn't like A times A and then A times B and then the
Okay, so you are going to advise me what to write. You will tell me what to write. So what do I write first?
A.
Remember, we will be applying the FOIL, ne?
Mm.
Alright, cool. So what do I write first?
A times A.
Okay, and how much is that?
A squared.
A squared, good. And then what do I do next?
A times B.
A times B. Which B?
Sorry.
So is it positive or negative?
Negative.
Okay, so we must also call out the sign, eh?
Yeah.
So it's going to be A times negative B. So that will be, what's the answer?
AB.
But the other one is negative, so is it just AB?
Minus
Minus what? Say it in full.
AB.
Minus AB, good. And then what do I do next?
Then you go to B, so it's gonna be B times A.
Okay, and what's the answer?
Is BA.
It's fine, but is it positive or negative?
Positive.
Positive. So let's write positive AB, okay? And then what else do I do?
B times minus B.
Okay, and what's the answer?
Minus B. B
Just minus B.
squared.
Excellent. Minus B squared. Okay. But then this is not complete. We still have to
And then
do something here. We still have to do something here. What must we do?
like terms.
Like terms. And what do we do to the like terms?
Add them.
We add them. Okay. So if we add negative AB to positive AB, what's going to happen there?
Gonna be AB squared.
If we add them, it does not become AB squared. Remember, we're not multiplying them. We are adding them. You're not sure. Okay, since we're adding them, let's think about if we have negative 3 and we add it to positive 3, what's the answer?
Answer is minus 9.
No, it's not minus 9.
I mean minus 6.
No, it's not minus 6. Think about it.
6.
It's definitely not plus 6. You're guessing now. Don't guess. Relax and think about it. So when I say think about it, let's say we're on the number line. Ne? There's 0, there's 1, 2, 3, negative 1, negative 2, negative 3. We're doing integer work. Ne? Okay. So if we have negative 3 and we are here, ne? Now we have to add 3. Which direction do we go?
Forward.
Like in this direction or in that direction? To the right. Okay. To the right is plus, to the left is minus. Very well for realizing that. So if we're at negative 3 and then we're adding 3, we're going to add how many times?
3 times.
1, 2, and 3. Ne?
Mm.
And where do we land?
-1. I mean 0.
We end at 0, right?
Mm.
Okay, so exactly this way that we're thinking about this is how we think about that. So now let's recap. If I have -3 and I add 3, what's the answer?
0.
It will be 0, ne? Now if I have negative AB and I add AB, what's the answer?
AB.
No. Because we've just done this example on a number line, and whilst it's a numerical example, we can see it. We don't know these terms, but we know they are equal. They just have different signs. And if we have numbers that are equal and have different signs and we're adding them, the answer is 0. So with the same reasoning, what would the answer be there?
AB.
It's not coming. Okay, the answer is 0. These are called additive inverses, ne? Additive inverses, ne? Do you know what an inverse is? Okay, so let's look up what an additive inverse is. Additive inverse. All right. So we will look up an additive inverse. All right. In mathematics, the additive inverse of an element x is denoted -x, right? So before we carry on there, let's just make a side note. Ne? Additive inverse. Let's start by defining what the word inverse means. Ne? Inverse. So an inverse or something that is inverse, it means it's reversed in order, nature, or effect, right? It is of or relating to an inverse or an inverse function or something that is turned upside down, right? So let's look at the first definition, reversed in order, right? When we looked at this number line here, we started first with -3. When we reverse it, the opposite sign for negative is positive. Yeah? So we say this all the time. Stop being so negative. Why don't you be positive? Because the negative is not desirable in that case. But now in maths, this is negative. What would be its reverse?
Positive.
Okay. So now when we are using, okay, that's good. So if we have something that's negative, then its reverse will be positive. Okay, good. So now when we are using addition and subtraction, ne? When we are using addition and subtraction, the term additive inverse becomes important. And now that's where, if we have an element, in this case we have -3, then its inverse would be +3, right? So in other words, if we have -AB as a term, then its inverse would be +AB. But now the end result of adding together the additive inverse is always 0. So in other words, you have to think about it as, what can I add to this number to get 0? Which is the same as saying subtract the same number. Still not clear.
How
It's... Are you sure? Are you sure?
Yeah.
Because this, understanding this, just this maths here, which is the same as that math there, which is the same as this math here. Just understanding this will help you to understand what we get when we apply this, and why in this discussion it's called the difference of two squares, and why that is important. Ne? Yeah, so if you don't understand that, this part, just this part here, it's going to be difficult to understand what this means here. Yeah? Oh, sorry, where is it? I'm looking for it. Geometry. Topic 8 doesn't look like it's got what I'm looking for. Anyway, it's called the difference of two squares. So understanding this part is important, because when we understand it, then we'll be able to apply the difference of two squares. So that when we have a plus b in a bracket multiplied by a minus b in a bracket, we know that we will not have a middle term. And it's simply because the terms in the middle, when we apply FOIL, they are additive inverses and they result in 0. So in other words, these cancel each other out to give us 0, or they add each other out to 0, and we are left with a squared minus b squared. And this here is called the difference of two squares, ne? Or rather, this here is called the difference of two squares. And it's simply because even when we use FOIL method, these terms in the middle, they will end up giving 0. That's the long and short of it. So you just remember that, and then whenever you see, even if you have 5y minus 4 times 5y plus 4, the answer will be 25y squared minus 16. Because when we apply FOIL, when you apply FOIL, it will be 25y squared. That would be plus 20y minus 20y plus, minus 16. And these give you 0. And this will be 25y squared minus 16. Another way you can think of negative 3 plus 3, it's that it's the same as 3 plus 3 minus 3. Ne? So this little activity here is what we call commutative. Ne? It means that terms in a mathematical expression can move around without changing the nature of the expression or the math you have to do. So let's look at commutative. Yeah? Commutative. Meaning. Yeah? Commutative means, So when you get on your school transport, you commute. You travel from home to school. That's commuting, right? It's traveling. So in other words, these terms can travel anywhere in the math without changing the truth of the math. That one. So negative 3 plus 3 and 3 minus 3 are the same thing. Because if we were here on the number line and we had 3 and we have to subtract 3, we would go minus 1, minus 1, minus 1, and we will land at 0. So this here would be negative 3 plus 3, and this would be plus 3 minus 3. So if I move the negative 3 behind the positive 3, it's still the same thing. It will still give me the answer of 0. So we apply the same thinking here. It's just that here, instead of having numbers that we are familiar with or comfortable with, we've got unknowns, which are a times b. So even if a was 1 and b was 2, that would be negative 2 plus 2. You get it? You get it. So even if here y, in the place of y, we would put 2 or 1, then that would be 20 times 1, which is 20, minus 20 times 1, which is 20, which will be 20 minus 20, which is 0. That one. It's the same thing. It's just that we are moving now from numbers that we're comfortable with to unknowns that make the math a bit spicy. That one. So don't be intimidated by this. Just understand, Hori, when I have a plus b in a bracket multiplied by a minus b in another bracket, that will give me difference of two squares, which is just I square the first term and I square the second term, but I multiplied by negative because of these differences in signs. Yeah, so perfect square and difference of two squares, they differ like that. And these differ because somewhere when you're doing the math, you get additive inverses, meaning a number subtracting the same number as itself so that the answer is 0. So again, commutative means relating to, involving, or characterized by substituting, interchanging, or exchanging. So interchanging would mean changing the order around. So independent of order, that's the second one. Independent of order means the order does not matter. Doesn't matter if you have the negative 3 first and the positive 3 after, or the positive 3 first and the negative 3 after. At the end of the day, you will still get the same answer of 0. That's what that means. So far is this clear?
Yes.
Alright, cool. So again, a commutative property in maths is a binary operation. So an operation between two numbers, that's what binary means, is commutative if changing the order of the operands being these numbers that you are operating on, changing the number of the operands does not change the end result. So the end result doesn't change, the answer is still 0. But we can write this one before or after, interchanging them, we still get the same answer. Okay, yes. There are some cases where that does not necessarily apply, and cases like that include we'll get to them. We'll get to them as we are doing many of these types of problems. But we'll get to them. Okay. So I just wanted to brush up on the discussion on what's this? Difference of two squares. Yes, that's what I wanted to brush up on. Okay. So just read this part. The signs.
The signs in the brackets are different.
Bless you.
So the last term of the product is always negative.
Yes, the last term of the product is always negative. So I wanted to go back to that discussion so that we can understand better what this discussion would be. It's always negative. And then what else is there?
The product is called the difference of two squares.
Mm-hmm.
Both terms are squares, and that is minus sign between them.
Yeah, so long story short, you have that one and that one, but there's a difference in the signs between them. So you just square the first term, you square the second term, but you multiply it by negative, and then it shade. Yeah. Then okay. Then what else can we do? So I will advise you to read through the summary for your self-study, ne? And then for now we can do. Are you comfortable doing these kinds of problems? Not yet, or are you? You're okay.
Yeah.
Let's try doing 1 to 3. Let's do 1, 2, and 3. So the first one is expand these expressions and simplify where possible. Right, so these are not necessarily perfect squares or difference of two squares, but the same rules of first, outer, what we'll still have to apply, and we also have to look at BODMAS. Ne? Yeah, so let's do some examples. Okay, so the first example is 3x, what is it? 2x squared plus 5 and close bracket minus 2x into x squared minus 6. Okay, what do you think we'll have to do here? What do you think we can do here to start? You can also read through there.
We start with the brackets.
What do we do to the brackets? What do you think we can do to them?
We can add them.
Not really. What does it say here? What do you think will happen if we multiply out like this first, and then we multiply out like that second? What do you think will happen? Should we give that a try? Okay, let's give that a try. So if we multiply 3x by 2x squared, what's the answer?
3x.
Yeah, 3x multiplied by 2x squared. What would be the answer?
It's going to be 6.
Okay, so 3 times 2 would be 6, definitely. But that's not everything. What else?
A squared.
X to the power, not squared, but remember, if we have exponents, remember, if we have x to the power m multiplied by x to the power n, the bases are the same, we simply add the exponents. So if x is to the power 2 is multiplied by x to the power 1, and we have to add the exponents, what would we get as an answer for the exponents if the exponents were 2 and 1?
To the power.
Yes, what would... So we've got x to the power m times x to the power n equals x to the power m plus n. Remember this rule from exponents. Now what happens if we have x squared times x to the power 1?
Would be x to the power of 3.
Yes, excellent. So it'll be x to the power 3. So we have the same thing here. So we've multiplied the 2 and the 3, that gives us 6. Well done. But now we have to finish off by multiplying the x with the x squared. And what does that give us?
6 to the power of
X to the power of how much?
2.
Remember, we are adding the 1 and the 2 as the exponents there. So what would be the sum?
3.
It would be 3. Yes. Then we take 3x and we multiply it by 5. And what does that give us?
15.
Okay, positive 15. Yes, but is that everything? What happens to the x?
To the power.
It's just x, but remember it's not multiplying anything, so it's just 15x. Ne? Alright, then we do the same here. So since the sign here is negative, it will multiply the first term and we'll still get a negative answer. So I'm just writing the sign down as negative. So we get negative 2x multiplied by x squared. What would be the answer there? It's still the same as this one. Still the same process.
Gonna be 2x.
And what's the power of that x? What's the exponent of the x? Remember,
3.
Yes, 3. Excellent. And then if we take negative 2x and we multiply it by negative 6, what happens? Negative times negative gives us?
Negative.
No.
Positive.
Positive, yes. And then we have positive 2. Sorry, positive. And then what's 2 times 6?
2 times 6. 15.
2 times
12.
6 is 12. Yes. Remember, you're being recorded. So if you get it incorrect, it shows you're not thinking about it. So we've got negative 2x times 6 will give us 12x. Can we simplify this? Yes, we can, because we've got like terms. I guess.
Yeah.
Yes. So what are the first pair of like terms?
15x and 12x.
Okay, good. So we're going to add those two. So it's going to be 15 plus 12. And what's that? How much is that? 27x, yeah? And then we're going to have 6x cubed minus 2x cubed. And how much is that? It's 4x cubed.
Oh, 4.
Yeah. So does it look like the one in the book?
Yeah.
Alright, cool. So, okay. So you see how we expand. So this part is where we expanded Yeah? And then here we simplify it. Yeah? Alright. So I know you said you wanted to follow these methods, but when you practice, I will encourage you to write out all of these and ask yourself, how did they get the 6x cubed? Ne? And also think about where that comes from. This comes from those exponential laws we did a couple of weeks ago. Yeah. And then, yeah, so let's do the second example. It's 7a minus 1. And then the second bracket is 8a plus 5. Okay, so again, here we can use FOIL as we know it was. Okay, so we'll start with 7a times 8a. How much do you think that is? $56a squared. Eh? Is your man
still counting?
You're still counting?
Yeah.
How are you gonna count it? I wanna hear. I wanna hear. 7 by 8. Eh? How are you counting it?
8, 9, 10, 11, 12, 13, 14.
Yo!
Like,
Yeah,
like
okay.
that.
So the quickest way I thought about it, I wouldn't say use that method, but I'd say maybe find other ways like that to think about it. So if you take the square of 7, it's 49. And if you take the square of 8, it's 64. So if you're going to have 8 by 7 or 7 by 8, that's the same answer. But it should be 7 more. Sorry, it should be 8 more. No, it should be 7 more. Yes, 7 more than 49 or 7 less than 64. So if you have 64 minus 7 or minus 8, sorry. Yeah. So it should be 8 less than 64 or 7 more than 49. That one. So if I thought about it from 49, it would be 49 plus 7 would be 50 plus 6, then it's 56. Yeah. If it's 64 less 8, then it will be 60 minus 4. So it will be 64, 60, then 56. Yeah. So that one. Yeah, just but I guess in grade 9 you're also allowed to use your calculator, so knock yourself out. Just always have it ready so that you don't get caught off guard. Yeah, that would be my advice. So then we have 7a times 5. 7 times 5 would be 35. And then we have negative 1 times 8, which is negative 8. A. And then we'll have negative 1 times positive 5, which is negative 5. Then we have to group our like terms. Then 35 minus 8 would be 30 minus 3, 27a minus 5. Is that the same answer as we get there? Oh, yeah, yes. Okay. So, but here, we basically just applied FOIL as it is. But since we don't have perfect square, we still apply the same process. But since we don't have perfect square, we can't say the one in the bracket, you multiply them together and then you multiply by 2. We can't do that. That would be wrong. That would be incorrect. So we have to expand it in as far as we can and then simplify. Yeah? Alright. Then let's do the last one. 4x minus 3 all squared. So 4x minus 3 all squared would equal, remember we square the first term, so that would be 4 squared is how much? 16,
Yeah.
16. Then we square the last term, or rather we multiply them. So 4x times negative 3 would be, let's rather do this. 4x minus 3. 4x minus 3. Then we've got 16x squared minus 12x minus 12x, yeah, plus did you just realize something? What did you realize?
No, the answer's like 4 and then you...
Yes. What did you realize now that you didn't realize before? Tell me that. Yeah. What did you realize now that you didn't realize before? Because I think it's important that we always...
It's the,
using the FOIL method.
Yeah.
Yes. So, Wawana, it's the same process that we learned before when we were starting this discussion.
That's the same thing.
It's the same thing. Eh? So, please, again, practice these. Because when you practice them, do you know what happens in your brain? You connect what you see with your eyes, with what you write in your hands, with what goes on in your mind, and also in your heart. So think about it like that. Think about it like that. That's why practice makes perfect. So when you do it with your hands and you see it with your eyes, it sticks better in your mind. And it also connects in your heart. That's as best as I can explain. But you have to practice. You have to practice. Then I think that's it for these ones. Okay. Yeah, so let's do these squares, square roots, cubes, and cube roots. Yeah? So it's squares, square roots, cubes, and cube roots. Do you know how to operate square roots and cube roots? On the calculator?
Yeah.
Only on the calculator?
Yeah.
That's okay, I guess. So can you just read for us the paragraph? I'll try and just listen out so that I don't disturb you, and then I'll just explain using these examples so that we can understand them better.
In topic 5, you learn the exponent rules.
Remember the exponent rules,
Yeah.
Alright.
Now you need to apply the rules when you have exponents and terms and algebraic expressions.
Okay.
Remember to write the basis as powers of prime factors when simplifying expressions. For example, 8x to the power of 3 equals 2 to the power of 3 x to the power of 3 and square 8x to the power of 3 equals square 2 to the power of 3 x to the power of 3 equals
Okay.
2x.
So, you know what is being explained there, ne? If you have square root of 4, ne? You can also write this as the square root of 2 squared. Something's burning. This laptop. But it smells like an electronic device is frying up. Can you smell it? Like a circuit is burning. Because this one's not heating up, so it's definitely not it. It's a charger anyway. Maybe it's probably from outside. Yeah. They're also saying that if you have the cube root of 8, it's the same as the cube root of 2 cubed. And that will just give us 2 cubed to the power 1 over 3. Or here we'll have 2 squared to the power half. Yeah? So that's what they're explaining there. To say, remember to write the bases as powers of prime factors for when simplifying expression. For example, 8x cubed would be 2 cubed times x cubed. Yeah, one. So 8x cubed equals 2 cubed times x cubed. So let's quickly look. Was it with you when we looked up what prime numbers are? Okay, do you remember what prime numbers are?
1,
Okay.
4,
It's 2,
2,
3, 5, 7, etc. Right? So those are what prime numbers are. And it simply means a number that can divide by itself or by that is greater than 1, that can divide or that cannot be formed by multiplying two smaller natural numbers. So it can be divided by itself or by 1. It can be divided by itself or by 1. Yes. Right? So let's apply this thinking here. Ne? So let's say we simplify the square root of 25. Is that a cubed?
yeah,
Okay, cool. So e.g. square root of 25 a cubed multiplied by 4a squared, yeah?
yeah.
Okay, cool. So how we would simplify this, and also you can look at this answer here. Ne? You can also look at this answer here because we're going to do the same thing. So the square root of 25 is 5.
It's a square.
The 4 has got a square root. Okay, cool. Okay. So we've got 5 like that, a cubed multiplied by 2 squared, a squared. Then this gives us 5a cubed times 2a squared. Now, since we've got a times a and they've got different exponents, we can simply add the exponents and multiply those, and then this gives us 10a to the power 5. You follow? Yeah. So that's the long and short of it. All right. We can do the second one. And that would be 2. Are you feeling tired? Yeah?
Yeah.
Yeah, it's tiring, eh? So this would be 2a cubed times b divided by
4.
4a squared b
Yeah.
plus
Uh,
the square root of, is it a squared over 4?
yeah.
All right, cool. So here, it's important to note that because of BODMAS, ne, the one that takes priority is the division. So we're going to have to solve first what's going on here. Then after we've solved what's going on here, we can then add whatever's left. Yeah? So we can say this is the same as 2a cubed b divided by 4a squared b, ne, plus a over 2, ne, because I've already taken out this square. Okay, let's do this instead. Yeah, a squared over 2 squared, so that we don't skip steps. I might just not be clear. Ne? Then 2 divided by 4 is a half. A squared divides there, and these also divide. So we're just left with a divided by 1. And then here, square root of a squared would be a, and the square root of 2 squared would be 2. And what happens is we've got a over 2 plus a over 2, which is a. All right. And the last example would be, also it's just one expression. So it'd be the cube root of 64 x to the power 6, ne?
Yeah.
Y to the power
3.
3.
Yeah.
Okay.
And,
Divided by
27
z to the power 9.
yeah.
To the power 9. All right. So this would equal 64. Let's see. I wouldn't know that one off by heart. 64. Oh yeah, so it's 4. Okay. So that would be the cube root of 4 to the power 3. X to the power 6, y to the power 3. That would be 3 to the power 3, z to the power 9. Yeah. Then that would be 4 over 3. So x to the power 6 times to the power 1 over 3. So 2, so that would be 3 there. Okay. So then this would be times x squared y over z cubed. And that is the answer. Yeah. And that's the final answer. So we can end here, but is that everything you wanted to learn today? Okay, everything you could learn today. So when we do factorization, I think we'll need to carry on from here as well, so that you can understand how we factorize algebraic expressions. Remember what I said, Jorge? If you have a perfect square, you can always think. And also that when we factorize, we need to learn how to expand expressions so that we can understand how to factorize them. Because from grade 10, especially when from grade 10, you will need to learn how to factorize, because if you have a parabola, for example, the answers you get for x, because x would be to the power 2, ax squared plus bx plus c. Ne? In function form, that thing, a squared minus 2ab plus b squared, looks like this, ne? And depending, it will look something like this on a graph, ne? Now, because of that, x is to the power 2, meaning there are 2 possible answers for x, ne? Now, if there are 2 possible answers for x, it simply means for x might be there or anywhere else on the x-axis, but there could be 2 answers. So if you know how to factorize them, you will know how to get where x is on the x-axis. But this is for like from grade 10 onwards. Ne? So don't worry about it yet, but factorizing is important to know because it leads you to this. Yeah, it leads you to that. Alright, so stop here. Are there any questions for today?
No.
No. Alright. But thanks for coming. Then I'll see you on Thursday.
Yeah.
4 o'clock. Alright.